Welcome to The Explainer. For over 40 years, preeclampsia has silently cast a shadow over countless pregnancies in India.
Today, we delve into one of medicine's most elusive puzzles. How can we detect preeclampsia earlier and manage it more effectively within the realities of Indian healthcare? Join us, Audicor, a sing few tell.
All right, let's get right into it. Sometimes in medicine, the body does things that, well, they just don't make any sense. They seem to completely defy logic. And today, we're diving into one of those really fascinating puzzles. It's found in preeclampsia, a really serious pregnancy complication, and it's all about the heart. So here's the big question, the central mystery we're going to try to solve. With preeclampsia, the heart is under this immense pressure, working against incredible resistance. Logically, you'd think it would just beat faster, right? To get the job done quicker. But it does the complete opposite. So what on earth is going on here? To really get this, we need to know about our key metric, the left ventricular ejection time, or LVET for short. It's actually pretty simple. It's just the amount of time, measured in milliseconds, that the heart's main pumping chamber, the left ventricle, is actively pushing blood out to the rest of the body with every beat. And this is where it gets really weird. This slide just lays out the paradox perfectly. Conventional wisdom, right, what all the textbooks say, is that when the heart faces more resistance, what doctors call afterload, it should shorten its ejection time. It tries to work faster to push through. But in preeclampsia, which is defined by that high afterload, researchers found the complete opposite. The LVET actually gets longer. It's wild. And this isn't just some abstract idea. We're talking about hard data. Recent studies show the average LVET in a control group was around 301 milliseconds. But in the group with preeclampsia, it shot up to over 320. Now, that might not sound like a huge number, but in the world of cardiology, that is a really significant and frankly puzzling difference. Okay, so the data is crystal clear, but the why is still a mystery. Let's start putting the pieces of this cardiovascular puzzle together. And to do that, we have to look for clues that are hidden in the very unique physiology of pregnancy itself. Our very first clue has to do with one of the most incredible changes that happens during a pregnancy. A massive, and I mean massive, increase in the amount of blood in the body. And when I say massive, I am not kidding. A person's blood volume during pregnancy can swell by a staggering 50 to 60%. This huge flood of fluid has a direct impact on the heart. It's what we call increasing the preload. So, all this extra volume triggers a really fundamental rule of heart physiology called the Frank-Starling mechanism. The easiest way to think about it is like a rubber band. The more you stretch the heart muscle by filling it up with blood, the more powerfully it's going to snap back. So this increased preload is basically priming the pump, giving the heart extra oomph to work with. But that volume factor, that's only half of the story. Our second big clue comes from the nervous system and a flood of stress hormones. See, in preeclampsia, the body's fight or flight system, the sympathetic nervous system, it just kicks into overdrive. It's basically stuck in a state of constant high alert activation. And how high are we talking? Well, plasma levels of norepinephrine, which is a key stress hormone, are found to be 2 to 3 times higher in those with preeclampsia compared to a normal pregnancy. That is a major hormonal surge. This adrenaline rush acts like a supercharger for the heart. It directly cranks up the heart's contractility, making every single squeeze more powerful and, this is key, allowing it to sustain that powerful contraction for longer. Okay, so we've got our two big clues, the volume factor and the adrenaline rush. Now, let's put them together and finally solve this thing. So here's the absolute crux of it. The heart in preeclampsia isn't just fighting high resistance all by itself. No way. It's armed with two really powerful tools to compensate. It's been primed with a high volume of blood, and it's been supercharged by a constant flow of adrenaline. And that's it. That's our answer. It's this 1-2 punch of high preload and high contractility that lets the heart muscle keep up a longer, more forceful squeeze. It can just keep pushing against that crazy resistance for a longer time with every single beat. And that is exactly what a prolonged LVET is showing us. So, paradox solved. But, solving this puzzle, it kind of reveals a darker truth. The source material puts it perfectly, saying this whole situation creates a pathological triangle. You've got injured blood vessels, a heart that's desperately trying to compensate, and a heart muscle that's actually being starved of oxygen in the process. So let's be really clear. This longer ejection time isn't a sign that the heart is strong and healthy. It's a distress signal. It is the heart screaming that it's working overtime, a sign that its incredible ability to compensate is being pushed to the absolute brink and could fail. And that is why catching this signal is so unbelievably important. If we can spot this sign of compensation early on, we can step in before it's too late. This is where some cool new technology comes into play. Tools like acoustic cardiography, which basically syncs up an ECG with heart sounds, can measure this LVET without any needles or invasive procedures, continuously and in real time. It's almost like we're listening in on the heart's distress call. And just look at the practical advantages here. I mean, it's a no-brainer. ACG is way cheaper than the traditional lab biomarkers. It gives you instant results instead of waiting hours, and you can use it pretty much anywhere with a small, portable device. And its predictive power is really strong. Sure, LVET by itself is a pretty decent predictor, but when you combine that real-time functional data with something as simple as a patient's history of hypertension, the diagnostic accuracy just gets so much better. I mean, this is a total game changer, especially when you think about resource-limited places, like Xinjiang, which was the focus of the study. There, the rate of preeclampsia is a terrifying 10.2%. So having a cheap, fast, and reliable way to screen for this, that could literally save countless lives. It really just leaves us with this powerful final thought. By understanding this strange paradox, why a stressed-out heart works longer, and by developing the tools to listen for its quiet signals, we might just be able to actually hear the future of a pregnancy before a crisis even has a chance to begin.
Bye.